This is question 3A from AS3 2005. The decibel scale is used in the measurement of levels of sound intensity. Explain why the definition of the scale involves the use of logarithms, and there's 3 marks. So first of all, ear sensitive to a very large, and again this is the same answer as we often hear this, ear sensitive to very large range of intensities. If you use a log scale that covers the entire range, now that range in terms of intensities and watts per metre squared, it goes from 10 to the minus 12 up to 10 to the 2, and that's an enormous range and impossible to display on one scale, whereas a log scale does cover the entire range and it can be displayed in the one scale. And the last one then, the ear's response, and this has come up before as well. The ear's response to sound is non-linear, or in other words, it is logarithmic, which means that the ear doesn't perceive a sound as doubly as loud. It only perceives the sound level to have gone up by a couple of decibels, if that's the case. B, part 1. An aircraft is waiting to take off from a runway at an airport. The sound intensity at a certain position near the aircraft is monitored by an inspector and found to be 82 watts per metre squared. Express this as a sound intensity level in decibels. And as usual, you're given your minimum threshold frequency there, or threshold of hearing. So IL is equal to 10 times log to the base 10 I over I naught. So your intensity is at 82. And you're dividing by 1 by 10 to the minus 12. And that comes out to be 139 decibels, which is a very loud sound, and that makes sense that it would be a very loud sound near an aircraft. Normally, when you're given intensities in a question, they're normally by 10 to the minus 5 or 10 to the minus 4 or something like that, so that is quite normal. The inspector wears ear protection, which reduces the sound intensity he hears to 3.2 by 10 to the minus 4 watts per metre squared. Calculate the decrease in sound intensity when wearing ear protection. So the intensity level has reduced the ear protection has reduced the sound intensity down to 3.2 by 10 to the minus 4. So calculate the decrease in sound intensity level. So it's already at 139. So what we're going to do is work out the intensity level for 3.2 by 10 to the minus 4. And then take those values away from each other. Take our 2 decibel levels away from each other. So when you do that calculation, that comes out as 85 decibels. And so the decrease is 139 minus 85. And that gives you an answer of 54 decibels. Suggest why the passengers in the aircraft do not need to wear ear protection. Well, usually the cabin would be soundproofed. It's probably the best answer there. Also, I suppose that they're not right beside the engines and so on, and there's plenty of soundproofing between them.